I am Christopher Davis, Assistant Professor of Mathematics, teaching Math 316, Real Analysis. So one of the main goals of the class is to, we'll give the students an introduction to real analysis. And one of the main things that you get out of that is actually making the techniques and all of the things you do in the calculus sequence of mathematics rigorous. So you actually have to build up the real numbers and compose the proofs of the claims that you make in calculus. So what we've been doing most recently in the class is talking about continuous functions and actually proving a lot of the things that get a lot of heavy use in the calculus sequence. We've proved the intermediate value theorem, we've proved the maximum principle, which you use in calculus a lot. And what we're going to move on to next is something which doesn't appear in the calculus sequence as much. We're going to talk about uniform continuity, and we'll move on to power series, which definitely don't get the rigor they deserve in calculus. So my minimum standard that I need a student to walk away from this course having is the ability to actually do an analysis proof. So in the calculus sequence, the idea of a proof using analytic proof in terms of some epsilons and deltas, it appears very briefly but is never really focused on in favor in the calculus sequence. Lots of computations happen instead. What a student should come out of this course being able to do is actually being able to prove at least some of those statements in the language of epsilons and deltas.